Good morning. Back live here. So the goal for today is to well, my goal for today is to maximize the probability that we actually have some sort of working world model-ish thing. Um, there's been enough work around this space, at least, that I don't know if I'm convinced that it's like good and stable on its own. I think with search, at least, there is. But something kind of occurred to me this morning. Let me get this started up, and then I'll explain what I'm on about. Hey, Larry, welcome. Morning. I'll explain what I'm on about in one moment. Hey, Kinvert. Okay, so let me sort of explain the realization that I've had. So let's say that you have a data set. They could be frames, they could be states, right? And these come from an existing environment, okay? And then you train your world model, we'll call it W, and it's basically just doing this sort of, state goes to S, D, right? So you have this world model that you're training. So the question here, and this world model, you're taking actions in it, and then what you do is you replace the environment with this, and you do, well, let me see, like reward, action, URL. So the question that I had here is, isn't this just going to learn exploits? Right? Isn't this just going to find everything wrong with your world model that doesn't actually match the real environment, exploit this gap, and use this to just like do things that maximize reward according to this model, but not according to this. Oh, also, you also get reward. AT. You also get this. Right? So the realization that I had is yes, you are going to train something to exploit this. Oh, welcome everyone. Anshul, something, Rick. How's it going? Can you explain world models or share the paper? I'm going to share the original paper, not the more complicated stuff. It's called world models. But the idea is quite simple, right? You learn a predictive model of the environment. So given state and action, you predict next state and reward. But the question here that I've always had with this line of work is how aren't you just going to learn to exploit gaps in the model? In fact, there's some results in this original paper that shows that you kind of do learn that. But the key thing that I missed here is that you're going to update your policy. Okay? You get your policy, and then this policy is actually used to collect fresh data, right? So then you actually get to test out data in the regions that your model has learned to exploit, and you're literally patching the holes. So in some sense, this actually is not a perfect like offline method. You actually do require fresh data. It's not like a batch learning method or an offline method, but if you do have fresh data, then essentially this is just like an alternative to off policy that fixes a lot of the problems that off policy has, right? That was the key realization that I had. Train the world model more than RL. You can balance however. But do you see what I mean here? So it's actually, in some case, it is the fresh data, the on policy, or not really on policy, but the presence of fresh data that prevents this from becoming degenerate. Welcome, James. So this is the key thing that I had, and as a result of this, combined with these results from this paper that I completely hate, but also from follow-ups that also are showing good results with similar things, that I think that this is actually kind of promising. It's that combined with me seeing how truly bad some of the off-policy stuff is that I've been working on. World model template. What do you mean template? There's no template. It's just an algorithm, right? So I can explain the beef I have with this paper generally. So it's a very grounded one, and I'm willing to admit that, if I can reproduce something like this, that the actual results are good. I've never said that the results are fake in this paper, right? I've never said that. The thing is, so this is our paper, published. We tried all these different tricks. We poured 20,800 hours into these experiments on the faith that, based on the authors here and all the work that they presented, that these tricks were, as they said, like these general purpose things for improving the stability of learning. We tried them in another setting where they should clearly work if that is the case, and they all completely and utterly failed. So basically, they kind of just grabbed a clever sounding bag of tricks and like bolted them onto their method that had a weak learning algorithm baseline, and then presented them as if they were the true solution to everything that everybody had overlooked in RL for the last decade. So that is the problem I have with this paper. It did an incredible amount of damage to the field in that sense, because I've literally seen like several people just using these random tricks, assuming that they work because of the pedigree of this paper. But you know what? If this actually does work and we can get something like this in Puffer, then maybe we'll forgive that transgression. No diffusion in here, Anshul. Basic world model stuff and go there. Yeah, so I think that it's likely that the basic formulation of this is reasonable. It's just that, like, it's literally half the paper devoted to these tricks, and they're all wrong. So that is the full context for what I have here. I will direct people to the start of this stream if I get questions about this during, because I've shat on this paper a whole bunch before. I do think it was incredibly irresponsible science. I'm usually not the guy saying that. But yeah, this here, I think that this makes it feasible. Exploits to the problem. I explained why I think that they're not because of this, right? Because you get fresh data. World models need load of data. No, the opposite. They need not very much data at all. Can two policies get merged? Two agents playing chess as enemies. Share the policy at the end. You could technically distill them, yes. You could do some form of distillation. The simplest thing I could think of would just be to clone clone the winning games from both of them. So just clone like the winning side of moves or whatever from each game. Play them against each other a bunch and do that. Explore otherwise falls apart. But the thing is, this fresh data metric, because you're training it to find exploits, essentially, then when you go you're intentionally sampling the data. It's literally learning to explore the areas that it has holes in the world model. I think that's why it works. And I haven't seen this explained before either. Maybe it's something I've missed in some other papers, but I think this is why it actually can potentially work. Um, so I am gonna just start on the hard task of actually doing all the research on this. I'm sure I lose like most of the viewers for the day as soon as I do that because it's the important work, but it's not necessarily the interesting work. I will just mention I really do not like short form content. I don't think it's generally a positive thing, but unfortunately, this is kind of the direction that the world's been pushed in, and I'm starting to experiment a little bit with these just because literally random clips from the stream have done better than like some of the content that's longer form I've actually put effort into. I'm going to try to do it in a way that's more productive and not just dumb clickbait, like actually contains useful information in shorter form. Hopefully more like 2-3 minutes instead of 30 seconds. But yeah, so that's up there if you're interested. Okay. Why world models? Because of empirical results, and she'll like if you just look up like the Atari 100K benchmark, which I don't think is a great benchmark, but still, if you look at the results of that, it's a trend. That combined with my confidence has decreased even more than it already was. It's gone even lower than it was before on off policy. There are just a ton of problems with off policy algorithms in general. This mic closer. All right. I believe where I left off, I had added a world model like as just an auxiliary loss, but I hadn't done much with it. So, right. The goal here, you need to have like some sort of state coder. I think you just need forward eval. Yeah, so what you need here, code. Oh. So this is this encoder thing, right? Just do this hidden. We're gonna have to clean this crap up, I'm sure. Okay, so we do this. And then this gives us the hidden. Yeah, this gives us hidden. Okay. And then where's our dynamics? Do you do generalized advantage estimation on this? Probably do, right? Let me see if we can figure out the exact formulation of this. There is code associated with this paper, but it's like it's borderline unreadable code. We're gonna see whether they actually work. I realized something about why they should make sense. Yeah, like this is wrong. Half the paper's wrong. Hey Finn, welcome. How the drones going? Just a little busy, no worries. Did self-imitation get anywhere? Um, it had some very interesting results, but also some tough to solve problems, I will say. It's actually just very, very difficult to get any sort of sample reuse into RL algorithms, it turns out. Okay. So they just do a 16-step bootstrap. This is... Well, I think I see. Well, we can do this. Yeah, we can... There's a simple way we can implement this as a starting point. We just have to take this thing. We're going to move this up. What do we do about advantages? No problem using this, right? Preference-based learning seems to work on and off policy. If you have, do you have anything that actually works, like, consistently off policy? I've tried a whole bunch of crap, and, like, off-pol learning just seems to not work. Like, basically, the problem with off-pol is that there's not actually a way to effectively bootstrap. So it's just like a super weak algorithm. And most of the things that are done to correct for this just don't work. Let's call it in general, Tim, where we're doing... Yeah. We're gonna try to get, like, some form of this working, drawing from the pieces I'm more confident actually work. Or pull faster. No one can do a data set. Does it work on anything else? Because basically anything I implement will solve cart pull. Like, I've gotten self-imitation learning to do that. I've gotten Q learning to do that. SAC will do that. I've done this with, like, several different methods at this point. If it works on breakout faster than, if it works on breakout in, like, fewer samples, or, well, I don't know, even fewer samples. If it works cleanly on puffer breakout, let's say, then I will take notice. Breakout seems to be, like, the minimally complex task that actually carries some weight to it, as far as I've seen. Try some more. Yeah, definitely let me know. So far, I don't know how you get around the bootstrap thing, though. Like, it seems like you kind of fundamentally just can't. You're kind of just screwed. Is this doing... This is still doing RL, right? I think this is still doing RL, right? Okay. Boards. Dynamic should be easy enough. We just take... Hmm. The state loss is going to be... difference between these. A whole bunch of different ways you could set this thing up. Gives you the state loss. Then we do here's a value. We're gonna check after this whether I'm doing any of this like remotely correctly. B term stays the same for now. Right, so you need so how the hell does this work? Need the initial reward. What? It's off by 1? It's off by 1, isn't it? Wait, hang on. This should just be The heck is wrong now? Advantages? Wrong on the second batch? Okay, is this wrong? Wait. Yeah, that's a full batch. Right, that is a full batch. How is this even remotely possible that this is the spot where it breaks? Okay, so you have your weights. How the heck did that happen? Oh, you dummy. No. Okay, so this actually does run. No way this trains, right? Yeah, no. So we now get to figure out what is the actual correct way to implement this thing. Wonder if there's a PyTorch. Don't understand. Like, I'd be so much happier if I just never had to interact with crap Python code. Literally, you look up the code and you get this. Should be in here, no? What the... Yeah, so Ryan, the tricks are all wrong, but I think uh there is something to the actual world model formulation. Yeah, I know, the code sucks. I'm just trying to figure out like the RSSM basically, that formulation. Like ignore all the other tricks, replace them with the new stuff that we have. Okay, but here's the thing that I didn't understand, right? Okay, here's the thing that I didn't understand. Like with world models, aren't you just literally training the model? You're literally RLing an agent to poke holes in your world model. That's what I didn't understand. Like how the hell does this even make sense? So this is the thing that I'd figured out. Um, right? You have like a data set, it generates frames. There's a gap between the actual data and the world model you're doing RL on the world model instead of the environment. It's literally being RL to exploit. But the thing I did not understand, right, is if you're RLing the agent to exploit the world model, you're also actually going and grabbing fresh data that is directly filling in those gaps. So it's actually kind of self-regularized. So like I actually in my mind, this actually makes more sense than like genie type stuff where you're completely disconnected. Right? But doesn't this make like this makes sense, but stuff like genie then doesn't make sense at all, right? Well, you say exactly, yeah, but you didn't make this point to me, now did you? So this is the thing that I didn't realize. Because the thing is, this is never complained about that specifically. Well, okay, fair. I was kind of too busy bitching about half the science of that paper being wrong, as we found, right? Like, I mean, when you literally have half of your paper being completely bogus, you tend to, like, throw the baby out with the bathwater, right? The other thing that made me take another look at this was the more recent, like, is this more? Yeah, more recent Efficient Zero 2. So it's like now you have multiple things taking somewhat similar approaches. And, um, and then I also put that next to some of the off-pol stuff, which just doesn't work as far as I can tell. Policy stuff for sample efficiency. So the again, it's the details are annoying. So the thing that I didn't realize specifically with off policy, you can't bootstrap like effectively with off policy at all. And all the like the methods like retrace, vtrace, all that stuff that claim to let you, they actually just tell you to not use the bootstrap data that's off policy. They don't actually let you use it effectively. Um, so you just have a worse method, like a fundamentally worse method in order to keep that off policy, the off policy assumption. And then they just like tune the heck out of these super brittle methods. Big reasons. Well, this is like again, this has taken me now like a full week of just going through. I've implemented like Q learning. I implemented SAC. I implemented like multiple different versions of imitation learning based stuff, like semi on Paul, right? And I got like some results across most of these as well. It's not like I just failed to implement them. Um, but actually honing in on this stuff takes time. So RL is on policy. Yeah, so I'm trying to find the details on how they do that. Do you actually know how it works off the top of your head? Do they just take like one step of interaction with the environment and then roll out 16 steps? Or do they like roll out segments and then like roll the model forward from each step? Do you know how it actually works? Real environment data. They sample those states as initial states. Imagine the next 6. That to train the world. Use that to train policy, of course. Which obviously we can replace that crap with our better on policy, right? Though interestingly, if it actually is strictly on policy, you might be able to get away with some other things. Yeah, and we have better than PPO as well, so from a world model. I don't know about that. I mean, they kind of just bombed when we tried them on like a stronger algorithm baseline, right? Wait, how do you roll out? Oh, I see. So you do it separately, I suppose. Robust. Yeah, we'll just crush that with giant batch sizes for now. Yeah, I'm kind of just assuming that we crush that for now. Well, I'm trying to figure out like a decent way to retrofit this initially, right? Like, I'm just taking. I'm trying to take like the first segment or the first step. So first time step of mini batch. I roll it out for BPT Horizon. And I collect like the imagined data. I use that for on policy learning. And then for the dynamics loss, right, I do. Do you train though? I guess the thing I don't understand here is the state loss trained via like one time step error, or is it trained via like the difference between the entire rollout of like 16 steps or whatever you're gonna do versus if you were to compute that function on the ground truth data? Is it like state and reward are like t to t plus 1 with the real actions or no? In all six. Yeah, you see, like there are a lot of details here that kind of matter. Figure it out. I don't even know if they have it in here. They're better open source. You're probably right. One was bad. Get the details. I'm trying to figure out how they do the rollouts, really. We can write half decent like training code. This is ludicrous. Actual baselines. Yeah, I'm just trying to figure out like the details of how I should implement this thing. Yeah. Do I do like from Dreamer V1? Yeah, no kidding. This does at least have an algorithm block. Let me just spend 1 minute on this. Okay, this looks like the dynamics learning is. Wait, how can it even be a one step? Right? Because you have an LSTM state, don't you? Yeah, you have a LSTM state. So it has to be then the full trajectory. Dynamics planning. Well, the original world model paper was just called World Models. Okay, let me see if I'm just doing something obscenely stupid here. I probably am. I've way overcomplicated it, right? Oh yeah, here. I don't even have to click that link, Ryan, damn it. I have to send you back to the sea mines of making NetHack fast over that one. Not the mines. Get you writing C for your postdoc one of these days. What are we working on today? We're working on world model based approaches. There's a few different things here. Scan that bot real quick. Really slow at writing. Wrap that up now. Dude, finish that thing. Like, how... I think I spent less than a week writing my thesis. Is that what you're still doing? Or is it a different paper or what? Research proposal. They make you submit that crap? Can't you just, like, type solve NetHack and just, like, submit it? Be done? Oh, fellowship. Yeah, that crap. I see. That's obnoxious. But the thing is, like, those are so bloody noisy anyways. Can't you just, like, stick it into GPT, call it a day, and get back to research? Like, I think I'm way better at GPT than at writing a good research proposal, but GPT is probably way better at, like, writing some bog standard bullshit that gets fellowships accepted, gets grants or whatever. Let me. Questionable. Get it right, yeah. Well, it's especially a good environment if you can just make it fast already. For which we have to send you to the sea mines. Yeah. Alright, so encode embed eval. Yeah, this is totally different, right? This is fine. If your embeddings, code train. Oh, yeah, this is gonna be totally wrong, right? Hey, boxing. Yeah, this is totally wrong. Because the actions diverge. Done with off Paul. This is an alternative to the same thing. Same problem in a sense. Okay, I think actually if I just read these. D. Um, Wait, but how? Okay, I'm not understanding how they're constructing the supervised losses here. I think I'm just not reading correctly. Coder maps stochastic or sensory inputs to stochastic representations, X to Z. The sequence model predicts the sequence of these representations given past actions a t minus 1. So wait, do you actually use the actions from the real data? Oh, do you not predict? Hang on. I don't think you predict next action. Wait. Okay, this is very different from what I thought. Given a sequence batch of inputs, actions, rewards, and continuation flags, the world model parameters phi are optimized end-to-end to minimize prediction loss. Wait, the world model and actor. Starting from the representations of replayed inputs. Imagined model states. Actions, rewards. No, it is imagining action. Hang on here. So the prediction. So x given z. Oh, wait. So xt given z and h. What is h? H is model. Hidden t minus 1. Does this? This is like your LSTM? Yeah. Okay, so this is... How good are you at predicting the next state? The real reward. Okay. There's also this continue thing. And then the dynamics are z given h and xt, the real input. Okay. So I think then I have this. I'm doing this wrong, right? I'd like to be sure, though. Is there any key way I can figure this out? Yes, freaking Jack's code. Never mind. Yeah, so it's the problem is the waters are very muddied around it because half the paper is just like clearly wrong. Um, I'm looking to see. I think that there's a salvageable core. I'm trying to figure out how it actually works though. Like the details of how doing these imagined rollouts. I guess the question is, do they actually train? Wait, reward model is Q5. Wait, no, this is Dreamer 1, right? Yeah, this is Dreamer 1. Maybe still useful. Let's see, this is saying imagine trajectories, predict rewards, and values. Compute value estimate. Okay, so this is the dynamics are learned with the real data. And the behaviors are done fully imagined. Okay. Think that makes sense. Think that makes sense. Doing this wrong? Yes, I am. Okay, because what we need to do right, the state needs to come after the LSTM. Right? Yes. Okay. Several things wrong. I think I understand this now, but I have to be like far more disciplined about doing this reasonably correctly. Um yeah, I think all I need to do is split encode and decode. Split out encode and decode. Be good. I think this is fine. Yeah, yeah. So you don't need this at all. Get encode eval. You also don't need this, right? Good train. To get your reward loss. Now this whole thing can be done like dramatically more efficiently, right? Okay, this does give us, yes, this gives us the hidden outputs for each state. This is good. World model's treating you. Um, Confusing, but we will be making progress. The goal is to get something that at least trains um beyond like trivial policy today. That's my goal. Okay, so this is going to produce our encodings, and then we need the dynamics on this, right? Which is hidden. Well, dynamics is meant to predict next state. Given this work, it does, right? Your position model. Am I just getting this wrong? Like, am I not using? No, hang on. The LSTM is supposed to predict. Do we just do like hidden next or whatever? Policy.g hidden and the real actions. And I think this works. Second LSTM, I don't know. The details are hard to track down. But I think what we do is we do state loss. It's going to be hidden. You're going to take everything from here. Going to do this. Okay, and now the reward loss. This is R next. And you're going to do the exact same thing, which is MB boards. Run. Oh, because we have to do the rest of this. We're gonna get closer here, though. Get closer. Let me see if this makes sense. We have our hidden state. This should just be encode eval, right? Okay, so this gives you your hidden state. Now you get your logits. Okay. And this comes from G. You get action reward. I think this is fine. It at least runs. Doesn't learn anything, but it runs. So now we have to figure out... You have to figure out some details, right? You have your trajectory segments. Compute model states S. Okay, so this is computing your hidden states. Update theta using reinforcement learning. Now something is different here. State theta. Using representation learning. How do we say... Yeah, I'm just missing details. Look at the different nets that he has. So he has H, takes HT minus 1, so that's the state. Takes Z. Is quite different. Wait, we have an encoder. Takes observation and hidden. I think that's confusing, as I think an LSTM can be both of these, right? Because wait, LSTM is going to take in previous hidden. Yeah, so the LSTM is going to produce a hidden state and a cell state, right? Okay. A different thing that predicts, given the hidden, you predict dynamics. Why is this such a freaking mess? H X. Okay. They just have this written really weirdly. Yeah, because the thing that's I think is throwing me off is these all take in hidden state. Wait, does this even make sense? So this takes in. Wait, this doesn't make any bloody sense, does it? So HT comes from HZ and A. Same inputs. Note the same network. Yeah, it's confusing as hell. That's what I'm trying to figure out. So the thing is, this is an LSTM, and then they're saying, okay, so the LSTM takes the previous LSTM state and the encoding of the observations. But then the observation encoder also takes the previous state in. Which doesn't make you like that. Does that even make sense? You get your hidden state. Your dynamics. encoder takes current state and current H. Well, how does this make any sense, right? Because this takes the encoding, takes previous. Does that even work? Is this not like circular or something? Previous state. ZT. I don't see how this takes hidden. Hidden take ZT minus 1. Like H0 is like, this gets initialized to 0 or whatever. To encode. And then H1 comes encoding this. Twice to compute figure 3. H uses Z. Wait, if this is the case, then is this even, can you even implement this as like a batch sequence model? Even make sense? I don't think you can even implement this as a batch sequence model, right? The data buffer. It's not, that's not the problem. That's for later. Yeah, there's literally no way to implement this as a batch sequence model the way that this thing is written. That's the thing that's driving me nuts, I think. Even use an LSTM. What is so if I consider, can I merge these two? Hang on. Why are these two bloody things different? Generated botch. Not the problem. They've done something super weird here that screws up the normal way that you use sequence models. Well, let's do and it's nan instantly. RSSM. They uses their. Hang on, what do they even use for this? Is the RSSM, does it use Oh, is this from... Okay, so it's from the first paper, I guess. RNN with auxiliary predictors. So it is an RNN. But they've done something stupidly screwy with the RNN, right? Okay, well, let me see if I can figure it out. And actually, such a question for you then. Do you know... Is this the RNN? And then these are separate networks? Or are these two the RNN? Yeah. Is this supposed to be the RNN right here? Because it's weird to me that they are including... The encoder is not just a function of the observation, it's a function of the observation and the hidden. Okay, so this is the RNN. Um... I don't understand how this takes the previous time steps. Is it broken? Which guys? He was an encoder. Yeah, but it's a weird encoder because it takes the state, right? Like, I would expect this to be Z is Q of X, and then HT is F phi of HT minus 1 and ZT. And then optionally AT minus 1. Also, where the heck is the action predictor in this? Like, they're missing the... They don't even have the action predictor in here. Doesn't have the action... What do you mean doesn't have an action predictor? It has to, right? It imagines full trajectories. Policy. Okay, so they just don't have it written there. They have it separate for some reason, even though it's part of the... I mean, the world model doesn't work without it, right? So... The sequence model takes... mess with... easier to imagine it like that. I don't think it makes any bloody sense either way you look at it. But with the way that this is, put the cell here, and then this is going to be F. Take C, A, and state, I guess. Trying to figure out how I position dynamic. Here. State. The main feature of the paper is putting out very good results while being half wrong. Trying to figure out the code doesn't help at all. Let's say I just like fully try to do this. I'm gonna have to like try to match almost completely. Did that. Very hard thing to implement. Yeah, and like the thing that bothers me with this paper, right, is it's very tricky to implement because it's poorly written and the reference code sucks. And then I have 20,000 hours of experiment showing that the entire, like half of the paper at least is completely wrong. But this is where we're left because there's literally nothing else promising that I've found. Like there's basically nothing else promising left. Like off-Paul's completely screwed. I mean, what's your alternative here, right? I've systematically kind of gone through most of the other things, and there's like nothing else promising. Like, we're kind of left with a set of hideously complex methods that have posted very good results with aggressively bad science. That's all that's left. And I can only hope that as soon as I get something that like vaguely resembles the original method into a reasonably correct form, that the scale, speed, and general stability of all the other stuff I've done in Puffer will work. I was like, what else do you do? Fusion based. Well, that's even more complicated. Also, what has done that? Do you have like a paper name or something? Or let me check that. What? Is this the result? Oh wait, this is pixel based is only, isn't it? Diffusion would be limited to pixels, right? Yeah, that's like an immediate no. Yeah, see, that's an immediate no. Limiting to pixels just screws the field instantly. Really, really bad thing to bake in. also works for robotics. People say it's stable. TD, model predictive control. Doing TD on top of classic methods. And I honestly don't trust robotics results as far as I can throw them. Like, of everything, I trust robotics results the least. They literally have the worst code, the least, like, carefully controlled benchmarks of anything. How are all the sodas bad on Breakout? It's 100k frames. Well, but like I can't use MPC for other stuff, right? Hang on. Not robotic specific. Yeah, that's these are not competitive benchmarks. I'm not going to trust that out of like with how fiddly like it could be like this could be good, but it's like with how fiddly RL is, it's like not even worth looking at without like independent voucher or something. Robotics hurt my feelings. I mean, literally just open any robotics code base, right? Like you have engines stacked so many levels deep. Like I find crazy things all the time in them. Um and like also like the tasks aren't usually controlled all that well. There are a ton of different freaking tasks. I mean, I hate Atari 100K as a benchmark, but at least for this stuff, I trust that over the robotics results even. Classic control method works with everything. Then it's just Dreamer or Alpha Zero. Classic control works with everything. Oh, okay. Yeah, I mean, like, search-based stuff, like, Efficient Zero is quite similar, right? It's, like, between those two. Mu Zero follow-up stuff. The problem is, and I looked at that, and it is better, but it's just obscenely, even, like, harder to implement, because it's all of this crap, plus, uh, plus tree search. And the search stuff is just like incredibly obnoxious to implement. No, search is harder because like to make the search fast, you're kind of just screwed. Made by guys who graduated. Yes, exactly. I noticed that. It's like generational trauma in a code base. Like insane. number of networks. At least now I have it 1-to-1 though, right? Let's see what this does. So for the sequence model, what does title mean? We're trying world model stuff, even though it's bitten me a whole bunch in the past. Doesn't need a concat. Just takes dynamics, only takes hidden. Then you don't need this, you just do call it, right? We'll make this enc. And you'll give Jax another chance. You know what? I'll tell you what. I'll do that as soon as somebody sends me a codebase in Jax that's not total dog shit. Transformer base, completely different application. A completely different application. And then reward. A separate branch for Dreamer would be nice. Look, yes, it will be. I mean, I will sync this to a branch. What made you change your mind on world models? The fact that I ran out of other things because off-pol was even worse. I'm like 75% sure at this point that that whole branch of research is just doomed. Like I was trying to figure out like, okay, what can we learn from off-pol research over the last hour? And it's just nothing. You can't learn anything. The algorithms suck. Alpha zero refactor for OpenSpiel. Yeah, that will be rough. Dreamer doesn't need to do explicit search though, Sacha. Which is why I'm starting with this. I actually like search as a like search makes a ton of sense. Um, it's like kind of obvious in some ways, but it's a total pain to implement fast. So we're starting with this. What did I do with this? Oh, it's a keyword. Do terminal instead. Okay. Get rid of all this crap. And actor and value do not need other stuff, right? Why the heck does this even need... It's so weird to me that this takes the obs and the hidden, right? Like, why? Back to no good way of learning. So because you can't actually effectively bootstrap off policy. Like, all the different correction mechanisms for bootstrapping off policy data just amount to, like, yeah, throw the data away. Problem? No, I think it's a bootstrapping problem. Just not been done. I don't know if it makes any sense in the way that it's formulated. Why should the obs parts be necessary? I'm confused. Like, this is not how any other recurrent model works, ever. So, in code, what is this saying? You take... This literally does not make any bloody sense to me why they have... Why they have the... I'm like... It just doesn't make any bloody sense to me that they have... Well, I suppose here, so this is... Okay, I do have this slightly wrong. Because it's the encoder takes... This is obs and hidden. So we can do hidden, obs, and then this is like hidden... encoding. Decoding. Wait, they got worse results without decoding? That's a major problem if that's the case, because decoding is not going to work. I can guarantee like decoding is just not going to work on non-pixel lens. Is there an ablation for decode? Because if so, I missed that. Figure 5. Is this the original? Wait, that's a super... Isn't this a super old one? This is Dreamer V2, right? They literally have this copy pasted, so... Yeah, I don't know which of these... Is there a specific figure 5 you said? Is it image gradients? Wait, is this image gradients? Is this what this is? We just bet. I mean, we'd better hope that's not what this is, because I mean that's just a mess. But that you would still learn through latents, right? Like doing this versus a pixel loss. Now that doesn't make sense to me. Like the search models don't have image reconstructions, and they have a similar method that works. Fig 6 in 2024 has no reconstruction grads. 2024, Fig 6 in 2024. Great delay. Yeah, that's just X being X. What does no reconstruction gradients mean? Wait. Yeah, the unsupervised reconstruction, but you can do this without going back to pixels, no? You do like it's Oh, is this like on top of the state loss? Around the fire just to make the images. Well, it like the difference is that like the method is useless if it only works on pixels. Where is this loss even? Wait, where's the... Well, wait, this is just not training any model if you take this out, right? I think that's just taking anything out. Like you still do the loss over like z to what is it, z t to zt minus 1. I just do not believe that the thing just stops working without a pixel loss versus a state loss. Equation 2. Equation 2 is just sum of all the losses. Okay, so um Model can't learn purely from latents. That's very poorly. Well, if that's the case, then this is all just screwed, Satya. And then the only thing you can do is the search-based stuff. Which I don't know how that gets around it. See you, Tim. Say something. It's a lot of work. Heck? Did I, like, miss a closing? Huh? What? Oh, now we're at value, okay. Just some syntax thing I'm not seeing. That's fine. Really? Streamer is not... is used in industry? I mean, what do you mean used in industry? Industry has no idea what they're doing at the moment in RL at all. Like, they're literally... the idea that, like, there is, like, actual, like, RL being done reasonably and correctly at a bunch of places is simply not true. Like, none of this stuff is widely known. The quality of the literature is generally too low. Okay, LLM RL does not fucking count. It is a trivial instance of an RL problem on a much larger scale that, like, makes the problem that would be very easy very hard as a result of the models being super slow. You have completely different algorithmic challenges. Let me know when you're doing, like, thousand turn, I guess they call it, RL. A 1,000 step is not 1,000 tokens. It's 1,000 interactions. If this worked, you would have coding agents that did not suck by now. Transformer world models? Not in RL, though. At least not publicly. Okay, so how the heck do we... Probably should still have a forward function, right? And then just figure out how to put it together. So... you do... dt minus 1. You need to literally put a third variable in here, don't you? All these releases. Stuff like Genie is completely incomparable. It's like a completely different set of issues. It's like not like it's so distant. It's not even the stuff there is not even remotely helpful to this stuff. Search stuff does actually. The search stuff seems like it can work. Yes, it's like hideously complicated though to do well. We'll do RSSMP then like this. Imagination steps. I'm working on that. Hang on. We're sure as hell not going to copy the original code because the original code's an unreadable mess. There's no planning step though. Like this method doesn't do planning. You could, but it doesn't. Okay, so this takes O device and state, right? So in this case, you do like this. The LSTM not taking in the current. Should I just like mess with this? Like literally this architecture doesn't make any bloody sense as it's written to me. Acting in imaginary MDP equals planning, not when you're just rolling out one episode, like rolling out a fixed number of steps with no options over it. You're literally doing that for like you're doing that for training only. It's not even done in the forward pass. The forward pass just executes one step. Can somebody explain, is there anything that actually makes sense about this at all, or is this just insane? Because, like, you're not even taking... You're not feeding the observation into the recurrent model. You're feeding the previous observation in. Sorry, I guess I'll keep it this way for consistency for now. We're gonna have to ablate this. Because in my mind, this architecture is completely insane. Okay, because you literally... The forward... So now you just do H hidden equals cell Z HC like this, right? and then you do C equals dynamics. It takes hidden, and no, it just takes hidden. Okay, and then you have to put the action, right? Logits. Paper make of heuristics. Well, the thing is, I know for a fact that all of, like, the tricks are just wrong. It's not. I'm not quite trying to replicate it. It's just I'm trying to get the world model portion from Dreamer without all the crazy tricks. I just want to get something that's like directionally correct today and starts learning on relatively easy problems. Like, the thing that I haven't been able to get right is a clean version of increase compute, decrease samples. Does not work. Self actors. Okay, and you return logits and value. So this we can do, right? So this is our forward. Didn't check my calendar today. Because of those hotfixes and ablations. Those hotfixes and ablations are crap. We've tested them extensively. They don't do anything. It's the reason that those do anything is that they used reinforce as a baseline. So they used literally the worst possible RL algorithm, and then they bolted a bunch of stuff on to patch it for that. We're not going to do reinforce. We're going to do, like, an actually sane algorithm. That's the problem with it. Gives you logits and value. I don't even necessarily care about the details of Dreamer specifically. It's either the world model formulation works or it doesn't. If I can't get a version of it, if I get, like, a version of it that's reasonably sane and it doesn't work in PufferLib, it's just not going to work anywhere, and it's just another of these, like, horribly brittle things. Oh, hang on. heck is wrong with this? Oh, because the actor doesn't need... Well, you would want the actor then to use... Want the actor to use both, right? So it would be torch, concatenate, observation. Like this. See how quickly it's running puffer end. What's a good speed for breakout? Depends on your specs. I think like 3 point something mil. Actor uses latents. Actor doesn't use... Actor doesn't use obs. Yes, you're right. So it's defined on just the state. Wait, state, but what is state? Wait, what? They don't even... Where's SD... Where's S even defined? No, H and Z, it does. You see this? They concatenate these. So it uses both. 4060 Ti, you'd have to look that up versus a different card. But the easiest thing is to just run it and see what you get. Like, run it with defaults. Okay, cool. We actually get to the train function now. I'm gonna use the restroom real quick. I'll be back in a minute, and then we'll see if we can get the train loop to run correctly or not. You know, I actually really like what Ryan told me, that the cool thing with the world model stuff is that it's on policy RL with respect to the world model, and on policy RL is the only thing we know actually works. About 1 million, 1.5 mil, half the speed of a 5090 is not bad. You have your own like over a million step per second RL now, so you can probably do things with that. Welcome to Puffer. Okay, so now we need to figure out how we compute this whole bloody thing, right? Oop. Well, this is the forward function. Model using these. Generate synthetic rollouts. Yeah. Yes. We're gonna kind of try to brute force it with like ridiculously big batch sizes to start, though. Like the goal is not to initially like make it work on 100K samples, right? Like I'm fine running it on 100 million samples and seeing if it can learn anything. And then we'll go from there. So you go through reward action, log prob, and value, right? Go through these. You need state. You do just do like this, right? So you do like hidden. We can just do obs state this, right? See you, Satcha. Thanks for dropping by. To me, grumpily just trying to fix this mess of a field we have. It is such a mess. Readable. All right, thank you. I will keep this as a reference. The link. Just port this into yeah. All right. Pulling me here. Now we do we're gonna not have pre-allocated tensors to start. So you start with this thing, right, like before, right? And then you go through and you do like don't. Oh yeah, we actually need to sample logits unbatched. That's so gross. So you get your dynamics, then Oh, that's disgusting. You can't even do this without the decode, right? Yeah, you literally can't do this part without the decode. Because you don't have access to the next observations, right? So I actually do then have to reformulate this without that component, because otherwise it's screwy. Well, that sucks, because that actually means I could have kept the batched version of this, and it would have been faster. But I guess we'll start. Let me just think about this. I'll make sure I'm not totally misunderstanding this. Sequence model. Code. Dynamics. Wait, what the hell's the difference between the dynamics predictor and the encoder? I actually don't understand this. What is the difference between the dynamics and the encoder? Z hat does not appear in here at all. I mean, I think I can do this, right? Like if I just switch it, I can switch it around a little bit. Wait, what is the one that predicts? No, I don't understand this actually. How do you predict next Z? Just we frickin'. Well, it's because you take in the action, right? Yeah, it's because you take in the action. Such a screwy model. Z. into discrete representation ZT. How is this discrete representation? I missed this. Code center into discrete representations predicted by a sequence model. Where's this discrete representation shenanigans? I totally missed this. Is this new in oh, hang on, they have this diagram. Does anybody have a simple version of this in PyTorch? Bloody RSSM doesn't make any sense to me. I can dump an encoding on this and make it technically work. Okay. Current model. Embedded state, the action. Return some. Welcome a private. Thank you. I'm currently bashing my head against a very screwy model. Create normal disk. Okay, so this is a sample-based thing. Weird. Most companies are not producing good RL work. Working over differences. Yeah, I mean, the thing is that the quality of the literature and the quality of the vast majority of the implementations in this space are so low that you just don't know what you're doing in this space most of the time. What I'm trying to fix, right? And I have actually fixed in one major area, which is anywhere where you have either fast sims or you can make a fast sim, and we make it easier to do that. High data regime, we have like very good simple RL now. It actually works. We don't have good stuff for low data regime, which is what I'm trying to figure out now. Oh, really? Is this how this is supposed to be? The sample base. I didn't realize this at all. Okay. Why the heck does it have to be, I guess it has to be a sampling based thing. Tricky. Screwy. Ah, wait, there. This is different. Sensory inputs to stochastic representations. Sequence model. Fix the sequence of these representations. I think that this is all coming down to screwy time step indexing, right? I host a Telegram channel with articles like this so I can revisit and learn everything better. A couple hundred papers related to this subject matter. There are not a couple hundred papers worth reading. Notice you've enabled automatic caption after the stream ends. Allowed me to download captions. I was the guy. This allowed me to download the captions. Can you check? Sure. I think YouTube is probably gonna prevent me from, or prevent you from posting it there. You can post it in the Discord though. Check or search the video. Yeah, if there's like a reasonably straightforward way of doing that, then sure. I'll check the link if you drop it in the Discord. Concatenation of these. This isn't a concatenation, right? Yeah, YouTube does that by default. I don't know if there's a way to... I have not found a way to turn it off, rather. Takes previous state, takes encoding, produces next state, right? And then hit the encoding. Oh no, this does work. Yeah, this does actually, I think, work. The only thing that's bizarro is how does the encoder need the previous HT? You can give it, right? It's like this thing. Very difficult. LZ. Right, because you don't concat the observations. Right, you concat is 2 times hidden size, like, yeah. This one's hidden. That was a simple mistake. Very simple mistake. You do the dynamics. You get your logits. You get your value. These actions. Log. And you need the action still, right? Yes. Those. Action. How long before Genie level world models are used for RL? I fundamentally don't think that idea makes sense. Like, at all. Like, in that case, you're explicitly just training RL agents to exploit your bad sim. Okay, so something like this, sort of, I think. Now, we also need to make the sequence model take into account action, right? Why does this sequence model have the frickin' action? get something to run first and have to play with this because it's just like the math is written in a way that like it just does not make sense. They cheat any way they can, even. I mean, look, RL literally finds exploits in physics engines, like actual game engines. You think it's not going to find exploits in this completely hallucinated model? Of course it is. Real model for RL. I only know of the concept from JEPA. There's been the thing is there have been a lot of good empirical results using them, but there also have been a ton of problems with the science behind it. So Ryan was in here before. I like the thing that he said, which is that you get to do online RL. You get to do like on policy RL, which is the only thing we know actually works on the world model. You basically get to do unlimited online RL. And then you get to actually ground that RL because whenever you drift off of the learned model, you go get fresh data that then grounds it again. So it's like an alternative to doing off-policy learning in some sense. With about the same amount of problems with the science's off-policy, but better empirical results. Can I just come up with a formulation of this that actually makes sense? Just separate dynamic. KL, because it's distribution, I suppose. Oh yeah, these are all samples, I see. Yeah, these are all sample-based models, that's why. Why not would be a fun stream. Why not what? I think I missed something. Continually rote memorize differences between these various modeling types. Variation of regression Python and RStudio. I mean, my guide is my own suggestion on how to learn this stuff is on my guide on X. Come up with a better algorithm. Well, that's what I'm working on, right? In some sense. The cool thing with Puffer is so fast, right? Like we can actually very rigorously test stuff. It's just tricky when the actual algorithms are so fiddly and so complicated, like they're so complex in their presentation. I think we have to give this thing action. We'll start here. Well, they look clear, but they're really not. Like, you actually go to implement the thing, and you're like, ah, this makes no sense. Type has no attribute dim. Ah, right. Can you not pass none to LSTMs? Oh yeah, no, you can't pass none to LSTM cell, right? Fine. I suppose the thing that's just like hardest for me to convey to people, um, the thing that's just like really difficult to get across, and you can hear me say the words, but you really can't appreciate until you've worked in the space for a while, is the extent to which science is not a clean process where you're just stacking up more and more progress from paper to paper. It's a very messy process in which like much, if not the majority, of published work is just wrong. There are things that are embedded that are correct, but actually figuring out what is robust and general and actually just works consistently requires piecing together patchwork ideas from a ton of different papers and like constantly updating your own estimates of like what is likely to work, what isn't, and then combining that with engineering at a level that is much higher than what is done on average by researchers in the field. So like just the extent to which the field is messy and like it's not actually straightforward to just take a thing, implement it, and oh yay, it works now. Like that's just difficult to convey. And we replace LSTM with transformer. Is performance better? There lacks evidence on that, I would say. Like there's scant evidence at small scale. They're definitely slower though. Just took in an hour. Yeah, exactly. It's like a totally different. I mean, this is the one thing I've actually been able to accomplish quite well with Puffer, right? Is like given fast sim. Well, we make fast sims rather, not just given fast sim. We can actually have RL work pretty dang well, and you can test ideas very quickly and without a massive amount of code. Right? You. I talk about a lot of this stuff in my guides as well. Like the most important thing to understand if you want to understand science is to understand a little bit about the process of how science is actually done. And when you understand that, it actually becomes pretty obvious why it's not actually like this pure thing where you're just like stacking up progress and like always pushing things forward. Like you realize why it's this amorphous thing where things constantly don't replicate and like ideas that sound good and seem to have evidence are overturned. Like when you understand the actual process of the PhD students and researchers who are overworked, who cannot run proper ablations, who are like trying to get papers published so that they can graduate or so that they can wrap up a project or whatever, like it becomes a lot more clear. Honestly, one of the coolest things when I was at RLC was just showing a couple of my colleagues who are newer to the field, just like taking them down from paper to paper and saying, "Do you see why that one's wrong? Yep. Do you see why that one's wrong? Yep. Do you see why that one's wrong?" And it's like you kind of just see the same problems over and over and over and over. And of course you do because the problems are born from the constraints placed on the researchers. Like research is done by people under severe constraints. And those constraints produce consistent patterns by which things are done incorrectly. Ah, I see. You. Okay, so now you actually get this imagined output. What do we do with this? We need the dynamics, right? Any reason why you reinit weights? Honestly, it used to be a thing. I probably could redo ablations and see if it's still required with the new optimizer and such that we have. Because I think it should be less sensitive. But it used to matter in the past. I don't know if it matters anymore. I mean, it's like it's very difficult with the amount of stuff I have to do in PufferLib. It's very difficult to balance my time across these things, right? Like I could be running extensive ablations on like what actually matters and what doesn't. I could be working on like simplifying docs and code. I can be working on like producing material in this space to get people into it. I have to be working at least at some amount on current clients and business expansions. I have to work on research side stuff as well, like you see here. It's it's just there's a lot of stuff, and it would be nice if I knew like, ah, yeah, we don't need these few lines, but the amount of experiments it would take means it's not super high on the priority list. It's more like for once we have at least everything in a decent spot. Build in seconds, think we can quickly make changes. Find out in 30 minutes, 36 hours. Yes. So I mean, this is actually one of the ideas I have for PufferLib is just I think RL if we just make this stuff a lot more sane and consistent, RL could become like the main entry point in AI for newcomers to this space, because we've taken this like really cool thing that used to be really really complicated, and at least right now for a decent set of problems we've made it relatively simple. If we can continue to push that, that'll just be more and more people into the space, and that helps guarantee progress. And even something like this, I can guarantee you that if I get this to work, if I get this to work cleanly, I can make the code clean. I'm very good at that. So I guarantee you, if we get this to work, in a way that like I'm happy with, I can make the code clean. Make any progress? I don't know. I've made a lot of changes. Can I figure out a clean way to get the lost at least? You should be able to have that work, right? This returns logit and values, right? You probably want to do the dynamics losses first, not second. You want to do like this. Out. Alright, and then what we'll do is we actually don't even need this necessarily, right? Yeah, Andrew, it's very, very complicated the way that these things are done. I thought that this was going to be the easier formulation. I should have probably just done like the simplest, like original world model stuff I could come up with without this crazy RSSM, like shenanigans and all this weird notation. Maybe I should still do that, I don't know. Five senses, essentially. Well, there aren't five senses designed for games. Nor do we even have sensors for everything with that. You can do audio visual. Tactile's hard but doable. The problem with tactile is you can't really simulate it super well. It's tough. Alright, so we do predict rewards for us. Creator with scaffold you can place instead objects. Types. Yeah, it's tough because, like, basically any like env engine thing that you come up with, it's just like doesn't cover all the cases you want, and things are so fiddly in RL that it's almost always better, at least for now, to just special case everything. Where do you see the field headed over the next 5 years? Um, depends what I'm able to pull off with this, honestly. Like, outside of what I'm doing here, like, there really isn't anything else that I see out there that, like, takes RL from these big, janky, huge projects to actually working out in the open, not behind closed doors, on things you can train at home and valuable, like, usable directly on a variety of different problems at companies, without having, like, gigantic, gigantic things. Really, it's depends on what I'm able to pull off. That's why I'm doing it, right? Because I think like the amount of impact you can have as an individual at this point is massive. Where would you like it to head? Um, I would like RL to be as mature as language models are now. I would like to see this like sane, simple, broadly used throughout robotics, logistics, games, and then my personal favorites are like scientific simulation based research. I'd like to see this kind of thread its way through pretty much everywhere where you have interaction problems, everywhere where you have sims, and to just change the way that you look at what you can do with simulation in general. I actually don't think robotics is even like I don't even think robotics is the most useful application or most interesting application of this stuff at all. Well, I don't know. If you make like a really really cracked out manufacturing bots, not humanoids, like really cracked out like multi-tool arms that build stuff super quickly, then maybe. But from what I've seen in robotics right now, it's not going the right direction for that stuff. It's kind of going to like a big hype cycle on slow, dumb, like jet supposedly general thing. Is it not a common sense idea that RL is the way forward? Yeah, it should be, but it's not because LLMs are super hyped right now, and most of the interest outside of Puffer around RL is purely around LLMs in a really, really dumb, restricted sense of what RL can actually do. What about programming? A lot of people yapping that AI can code flawlessly. Well, I mean, those people simply can't code because, like, it's not remotely close to doing anything. If you actually solve programming, you solve basically everything, but, like, it's not remotely usable at the moment for any of this. Like, a lot of the well-known researchers that are saying that it's really good for code, it's just like, have you seen researchers write code? They write awful code. Physics-informed models would be beneficial if you're thinking about physics-informed models. If you mean like building better physics sims, yes, that's one thing that we can look at. Uh, that's like a really big problem though for one area. I like that's something that we'd have to do as like a somewhat larger project if we wanted to take that on. And it's kind of separate from fixing RL in a sense. Well, not always. We make like a couple dedicated sims for control tasks at the moment. General physics engine a lot harder to do really well. Any kind of paradigm shift for RL system big. Well, I mean, if you look at the traction we've got from basically me plus open source contributors hacking on stuff in the last year, it's working incredibly well. Like the trend is there. It's just a matter of like delivering the next few algorithm updates to Puffer and then continuing to iterate on speed and efficiency and everything. Give it a structure, implement it in the best way. But like giving something structure is not harder than actually implementing it is the thing. Psychiatrist X reinforcement learning. Yeah, people are trying that and it's a terrible idea. Don't do that. Though I'm probably a bad person to ask because uh my view of therapy in general is running and deadlifts. So I'm probably a bad person to ask for that. Okay, so this does give us. We just do deltas on this, right? No, we don't just do deltas. Wait, what? We do. Oh, this is why you have to have the separate prediction model, right? Yeah, this is why you have to have the separate dynamics prediction model. How a person thinks and apply that to RL research. Oh, I see. Um, it's tough because, like, one, biological analog is not the only path to intelligence, and two, you're confined by, like, what you can do in a way that is efficient with hardware that we have or can build. So there is going to be a fundamental difference between what we build in silicon and what we build in biology, or what exists in biology, just due to the difference in the types of operations we can perform. What do you think about TSO Ding, Twitch guy coding C? I haven't really seen any of his content other than like random tweets. Seems cool. I don't know. People often think of like C as this super hardcore language or whatever, and it's not. It's like C is my favorite language. It's just super simple. It's fast and it's easy. That's it. Like it's gotten like a weird reputation from people massively overcomplicating things. Like any modern programming language is way more of a mess than just writing stuff in C. Bits a second. Bits per second. Um, that can't possibly be true. That can't possibly be true. How you implement the algorithm in Python? Um, you really can't get away from Python in deep learning. It's a faster prototyping language for this type of crap, mostly because of how much stuff has been optimized for AI, like specifically. But like technically, yeah, it like the code for this really would not look much worse with a well-designed C backend. Material science. I need to get back to the material science. I really want to. It's the application I am the most excited about, frankly. I've just been stuck doing a bunch of other things. Like, it's really. If I get this to work, for context, like, it will just, like, Puffer will just solve everything, basically. If I get a good version of this in Puffer, like, this basically will bridge the remaining capabilities gap, like, qualitative gap, and everything from there is just optimization. Add research scholarship on this. 10 bits per second. It can't be 10 bits per second peak. It may be average, like you're just not doing anything most of the time or something. But like literally just playing an online game or something, there's way more than 10 bits a second worth of information that you have to process. You could say that you can compress things into 10 bits of decisions or something, but that's not the same as there being 10 bits of information being processed. Material science problem solely and solve something. I mean, I would like to, but the reality of it is, right, Andrew, that the most practical thing for me to do, if I really want to push RL forward, is to throw this on the first problem that brings in a sufficiently large contract to fund a large expansion of Puffer as a lab. That is the most practical thing for me to do. And of course, not get so distracted just chasing that I don't actually do research. Duh. Um, but it does need to scale just a little bit. They're distinct from the brain. Well, then that's like saying there's like you're not counting the encoder as part of it, but the encoder is part of it, right? How do we do? Protein folding is a sequence modeling problem, as far as I've seen at the moment. It would be more like molecular interactions, like multi-molecule interactions. You reached out to Google. What for, Andrew? How much faster do you think Puffer would be if the algorithm were also implemented? A little bit, not a ton. I mean, frankly, there are a whole bunch of. It's not about C like versus Python necessarily. It's more so about like the number of CUDA compilation steps and graph calls and like kernel launches and other things. There are other bottlenecks that I could optimize from either language first that you would hit. They're like way more significant. Where's this thing? MX given H predict Z. You need dynamics. You need hidden as well, don't you? Okay. Yeah, but like they're just simply not going to do that, right? This Let me see if this runs. We'll have to check every dynamics code. Play. Ah, drones for Kubernetes. No, they're we have Finn and Sam are still doing stuff on that. Look, I went to RLC. I thought about a bunch of research. I got a bunch of ideas. Now I'm spending a couple of weeks splitting my time between making sure existing clients are happy and um working on research follow-ups. It doesn't mean stuff's abandoned. It just means I'm like working on I'm trying to like see if like I'm looking for core improvements right now. The heck did reward happen? And a bit about RL while researching LLMs. Repeat tweet of the paper award and streams inspired me to study RL from fundamentals, watching Sutton's videos on future AI. I don't know if Sutton is the best person to watch on that anymore. Definitely for theoretical fundamentals if you're interested in a mathematical point of view. It depends what you're interested in, to be fair. My guide covers a lot of the like engineering and practical stuff as well as like what to read to like to start working on things that actually work quite quickly. Though I admittedly I don't really take as I don't pay that much attention to a lot of the foundational stuff because a lot of it just doesn't translate into algorithms that consistently work. Okay, this runs. I'm sure this doesn't train, but it runs at a decent clip as well. Okay, so we'll start going through this. Needs to be action conditioned, need to like sanity check a ton of things, but hopefully we can get something directionally correct relatively soon. Already 3:15. Got about another 3 hours, a little less to work on this today. Research is tough, you know. You end up just putting in a ton of time for I mean like things just don't work consistently. Be right back. Can you suggest some people to follow for staying with the latest RL and AI? Those are two very different questions. There really are not that many people in like doing this type of RL work these days, frankly. Like you're best served just like checking out all the stuff people are building in the Puffer Discord. I mean, I can tell you the people who were very, very influential in RL who don't really do a ton of it anymore, right? As well as like people who've done good stuff in the past, but these days there really isn't a ton of this type of work. That's why I'm doing it, right? I guess DeepMind is still doing some. There are a few labs, not a ton. If we follow this exactly, and what we do, yeah, it's like 90+% LLM stuff these days, even in RL, which is unfortunate. I'm still holding the fort down here, you know? In '08 and '09. Oh, it definitely didn't work at all back then. Doing like tabular Q learning. Didn't even get a DQN back then. Because actions. Oh, because you zeroed me. Yeah. That's a pretty new. I mean, that's a pretty new development, right? Oh, because this is dummy. Very dumb. Yeah, it turns out that like if you're smart and you don't want to like try to write a smart algorithm, you just want to like hack your own knowledge into it, you can make stuff that's very convincing if you spend enough time. Okay, I'm sure this is still not working, right? But at least now we have the pieces in place. What do you see as next step to moving past transformer? I don't know if that's an architecture limitation, though. Why would you think it's an architecture limitation? That doesn't seem like a clear... That doesn't seem like a clear-cut thing. Goal now, I think, is to just do the simplest possible world model formulation that would work from here. Let me think about what that would be. Not that far off of this. I guess it would be, let's do like one-step predictions to make sure we haven't just completely broken everything, right? What do you mean it doesn't emulate how we experience the world? How the heck do you know how we experience the world? Suggesting. Oh, that would be mostly like memory, presumably. I mean, that's more how you present information, honestly, than anything. Away from implementing world models here, you're doing it in PufferLib. Attempting to. Things are a frickin' mess. Here's what we'll do. We'll do it this way, right? So this now. Here, we'll comment this one. And so we go through like this. And we're going to do A. Log. Grab state, reset. Do like this, we get the state reset, right? So we should kind of do this anyways. Up here. The idea here is that yeah. So the idea here is that we do one-step predictions. So one-step predictions should be very easy to learn. Yes. Jesus. S. Latin. Tricky. We just want this, what, batched? Unbatched. Matter? That doesn't. RLVR. Wait, what? RLVR world? I don't know what that is. Like, which one? I really am not working like crazy long days, but holy hell, this stuff is exhausting. Yeah, it turns out that when you like get up, do 3 hours of exercise, and then spend the whole day doing like hard research, it's kind of tiring. Exhausted. Yeah, here, bot. Put in the Discord. See. Holy Discord. Oh. Why did this open in full screen like this? Did you put it in dev? Oh. Uh I actually, what the heck was this? Somebody linked me this. Wait, what? Did I even look at this? Was I even looking at this thing? Yeah, I don't have any recollection of this. Are you sure that's the one I was looking at? Like, I have no recollection of that at all. I don't, like, I've never read that. similar. Not sure. Yeah, I don't think that was the same one. Okay, so this is like this is the simplest thing that should work if we have it implemented correctly, I think. And this house from freaking freezing me. I'm gonna take 2 minutes, warm myself back up. For some reason I forgot that I had the AC on like 65 degrees. Freezing. Alright. Forgot that I had the AC like on for cold. I'm like wondering like why is it so cold today? Oh, because I literally have my AC set to Arctic. Alright. So yeah, see this is now a thing that should be like relatively straightforward, right? Go actually to the original P4. Of course, it's super slow. For loop. I mean, I guess another thing we could do as a sanity check would be um well, FBR, I think that it's possible that with optimization we could get them to be it's possible we could get them to be equal wall clock, but like way more scalable, right? Like no, we should definitely be able to get them to be equal wall clock. Tech. It's not about if the tech gets there. It's if I can get it to be if I can get an implementation to work, and then it's a matter of me sitting down and doing a bunch of engineering. No like speculative portion about other people having to contribute these things. Hard though. Yeah, so if this doesn't work, then it's just like we've broken some stuff, right? Yeah. I'm trying to debug it, that guy. Normally a big wouldn't put it past you, yeah. No, I'm very confident if I can just get something, if I can get this into a space where it's like doing reasonably, I can take it pretty far from there. The main thing is just like getting something that roughly approximates reasonable result. So there's some other thing I could do. Forward log prob val, right? Well, first of all, we can just comment all this dynamics crap now. And then we just try have this sequential rollout thing. Action reward log prob and value. Entropy would be a cool thing to have, don't you think? I mean, it is pretty much a matter of how stubborn I'm going to be about making this thing work, right? Like, I think we should be able to get something. How are actions computed in this? I'd like to just bring this more in line with, I think the best thing I can do is just bring this more in line with, like, something simpler and saner. I'm gonna modify this. So this is doing, like, a bunch of non-standard weird things. Easiest thing to do, frankly. I'm gonna play with this until it's something that I know will work. And paper. to make this frickin' work. Action. Okay. And this still doesn't work, then we have some severe problems. You look tired? Well, that's what happens when you get up, do 3 hours of exercise, and then do hard research all day. Progress must be made, though. Yep. I'm trying to get back in decent running shape without completely screwing up my knee. We'll see. And yeah, of course, the research is. I mean, if we get something of this variety working, it would be a big deal. It's just tricky. Logit's value equals policy, device, and state. Doing the same research. I mean, screwing around with world models in some capacity, yeah. Like doing exactly what I'm doing with the backing of all the puffer infra, like not at all. Like the puffer infra is what makes this remotely doable. Otherwise, like any new project you want to do is just like months and months and months. PufferLib and OpenAI Gym, about a factor of 1,000 in speed. Also, Gym doesn't really do anything other than like give you an environment interface. Puffer gives you all the other things. Like there's no training implementation in OpenAI Gym. There's like it's really just like an API for some built-in environments. I mean, if you play with PufferLib, right, you'll see. You can actually just train stuff in seconds. Thank you. Wait, hang on. This is the problem right here. Yeah, like still learning basic statistics and deep learning RL still so far from me. I mean, honestly, you really don't need to spend a whole bunch of time studying statistics to get into RL. Like my guide is pretty accessible. The guide I have on X is pretty accessible. It gets you like actually implementing environments and getting RL training within like the first several hours. First few hours really if you already know how to program. You're like competent. Try to understand everything. The problem is that you can't in RL because like you can go study the fundamentals and think you understand stuff, but then you'll go to actually implement things and it won't work. Like the fundamentals don't actually translate to what works in practice. There's a very, very big gap. You're way better served like learning what works and what doesn't and then filling in theory gaps along the way as you're interested. Let's just do this. Comment all these extra freaking layers out. Now this we'll make this like equivalent basically to what we had before. Now if this doesn't work right, then there's just bugs. It should be equivalent to what we had before. Very different form. You can code observations and actions. What you want. Cell. Good. Here. Take in your Z. Cell. You get logits. How's Dreamerland? Spencer, this is exhausting. This is completely exhausting. Cheers. No, I wonder, is this go here? Goes here, right? You know what? So bloody complicated. Just make sure I'm not handling... Let me just make sure I'm not handling action wrong. Have your encode, cell, actor in the value, right? Be fine. I mean, I suppose we should probably put this little Gelu back. That does anything. So Spencer, I was trying, except like obviously without the dumb tricks that don't work. This paper is incredibly complicated. Most of the reference code is like unusably bad. They're like a whole bunch of problems. Yeah, this honestly might be honestly, I kind of want to just commit this and then start fresh from what I know now. A new branch. No, we're not doing pixel bullshit. It's useless if it's only pixels. Like it's actually just useless if it only works on pixels. It's really hard to trust anything other than that the result exists. I mean, it's literally like it's the equivalent of like if you go to buy a house and then you like open the boiler room or whatever, or like you go to the basement and like all the columns holding up the house are just like broken and taped together with duct tape, and the boiler's got like all patches on it and is like, made of a whole bunch of different materials that are just like patched together over 50 years. It's like damn, you live like this? It's crazy. Okay, so this is the stupid simple loop version. Yep. So this is the simple loop version. Note that it's 3 times slower than Puffer. That's why nobody uses LSTMs and RLs, because they all do it wrong. You need to kind of figure out how to do it fast. Otherwise, you do it like this and it's slow. Did you write that CLI with Rich? Yes. How does it say at the top of the terminal? Manually clearing the terminal every time it prints. One of the main things I'm very happy with the Puffer UX. Don't use Claude at all. Go to research. Most suitable. It just gets in my way and wastes my time, man. These models are not actually smart. Best model is this one. You see this autocomplete that I get? Super Maven. Really stupid model. Really small. Really fast. Saves me typing. I do noticeably miss that when, if I'm not using it. I can code without it. It just, it's obnoxious having to type so much more. But that's about it. Okay, so succeeded in adding a couple auxiliaries without breaking anything. Good. Dynamics have to go. Well, sequence model has to take into account the action, right? Dynamics has to predict the next Z. We have encoder, we need to add dynamics. Do this, and oops, damn it. Just to keep you on your toes. Roll at random. With off policy, this is an alternative to off policy something. They serve the same purpose in a sense. Off policy, at the very least, has been downgraded in my mind to less promising than this. Like, I found, like, a lot of the fundamental limitations of it, I think. Like, basically, you'd need a clean formulation that actually handles bootstrapping in a reasonable way. And I haven't seen one. In bootstrapping, the framing of it, it just doesn't work. Like, it just straight up doesn't work in off-ball. Right. So what we do is use Z. $11 of work. Better check on PufferLib. No, there have not been any major developments. Mostly me fighting this crap. Mostly me just fighting this crap, man. Problem. Now, let me read that in a second. What do you think of applied projects, neural data in RL? Neural data. Like actual brain data? Working on tuning hyperparameters of the model while it's learning with intrinsic neural data. Range exploration based on how the human neural data sees it. Where... So, like, where are you going to get that data in real time? The whole thing with RL, right, is like the thing can train like 10,000x faster and just suck up way more data than a human can. As soon as you put a human in the loop, like, yeah, there's work on this, and it like, you can use human input in some ways. I haven't seen human neural data, but you can use human input in some ways. You just, like, everything gets slowed massively down. Use a human to guide. I found PufferLib. Why should I slow the model down to 2 steps per second? By training a million steps per second. Yeah, I mean, this is kind of the key thing, right? Like, if you can ever just turn your domain into a high data regime domain, that's the easiest thing. I'll change it to hyperparams. I mean, there's all sorts of automated stuff you can do with hyperparams if you want to go that direction, even interactively. You can look at, like, population-based training. I don't necessarily think it's a great algorithm, but it does kind of do this on-the-fly tuning thing. Thank you for the reminder, Bet. Yes, do star PufferLib for everyone watching. It really, really helps me out. Join the Discord as well if you want to get involved with everyone. The research or on building out environments. 5. Well, this actually gives us... Well, let's just see if this totally crashes or not. Nothing has made it work, that guy. This is me stripping... This is me, like, trying again from starting from 3.0 and incrementally building up towards an implementation that looks like a world model thing. This is not a world model working. This is at the moment just like a slow version of PufferLib with a bunch of auxiliary losses in there. That, like, the code structure is such that it's very close to how it will have to be for initial world model stuff. Realize the world. Um, Not really, because you have to train pixel models, which are freaking slow. If somebody comes up with an alternative to comms that, like, big stack of comms that's fast, then sure. Freaking starving today. Well, holy. That's catching up with me. Okay, so don't get enough information. Based obs. Date? No. There's no way in hell that it's a pixel specific thing. There's just no way. It wouldn't make any sense for it to be. Why you can't reproduce pixel obs. Like this is already a factor of 4 slowdown. I'm not going to take a factor of 100 slowdown and just have the experiments fundamentally not work in a reasonable amount of time. Okay, so this is something. This is something, I think. If I'm correct, this should be now using the learned one-step reward model. So what I can do is I can swap in like a one-step world model and learn through that. And then I can ablate it upwards. Is that the baseline was done with pixels? Yeah, but the baseline is a complete hot mess that, like, there's just no way you're going to be able to go do anything from that starting point. It's like a total mess. There's also like no way in hell I'm going to be able to reproduce the paper. It's like I'm going to be able to get a world model type thing and iterate on it. Type thing look like. Um, it looks like you collect your data like normal, but then instead of actually you train a supervised model using the data, and then you use the supervised models to like hallucinate game data, and then you do RL on the hallucinated data. That's what it looks like. Apparently, bet. Apparently. And just to show that this is actually doing something, if I multiply this by 0, this fails, right? How the hell is it learning without rewards? Oh, it still has the values. It should be way better like this, right? What's the solve? Baseline 90 mil. You can make it faster as well. Huh. It's actually just like not using reward at all, is it? Crazy. Figure that out. Time is it? 5. Technically, I have another hour before I gotta go get dinner. Be tired, but okay. Think. Do we want? Do we want to use like one-step obs replacement here? This surely doesn't work, right? And out. Okay, so can I do this one step somehow? I'm kind of out of steam, I'm not gonna lie. Yeah, that's hard. I'm gonna try to solve this one last thing, though. That's how it is with this. So even the one-step prediction, if I've done this correctly, is kind of hard to learn. And there are a lot of explanations for that, right? I do think I am going to call it a little early today, though. I am, like, exhausted from this. A lot of work. Goal will be come back tomorrow. See what we can do with this stuff generally. And, I don't know, we'll basically decide, like, how much effort I think it's going to take before we could get something like this working. I would think that there should be, like, there should be some reasonable formulation of a world model that we can get working decently well quickly. Maybe I'm wrong, though. Anyways, folks who've been tuning in all day, thanks for stopping by. Let me go grab a couple quick things from over here. If you're interested in reinforcement learning or my work generally, Puffer.ai for all the things. Or the GitHub, it helps me out a ton, it's free. Join the Discord to get involved with development or to learn more. Follow me on X for a whole bunch of RL content, including articles you can't find anywhere else. Thank you, and I will be back tomorrow.